Hi, Algebra 1. Here is the second part of our lesson, and it finishes up section 5.3 that we started yesterday. So this should be corresponding to Wednesday's lesson of this homebound learning week. You should have, again, your note packet in front of you, and we are going to pick up where we left off at number 4. Now, to review before we dive in, we are talking about our slope-intercept form of a linear equation. Y equals mx plus b, where m is my slope and b is my y-intercept. So for problem number 4, we are going to be given clues, and we need to be able to write the equation from the given information. So for number 4, it says, what equation represents the line that passes through 2, 1 and 5, -8? So this question is asking, there's the question mark, what's the equation of this line if I'm given 2 of my points? Now, I could plot this line by putting those 2 points on my graph and connecting them, and then doing the same exact problem we did number 3 yesterday. But I'm going to show you that we don't even need to draw a graph. But we still need to get the same information. So just as we did in number 3 yesterday, I need to remember if I'm dealing with slope-intercept form, I need my slope and my intercept. Well, this is a little bit trickier this way. And the reason that it's best not to draw a graph and then go from there is because sometimes our y-intercept isn't very obvious or clear on graphs we make, myself included, as you all know. So the best thing to do is to solve this using algebra. And so you see on my board, I have steps 1, 2, and 3 listed here. You need to write these on the side of your notes, maybe in the margin, so that you can refer back to this when you have problems like this to do for homework. So the first step, find my m. Well, I don't have a graph that I can interpret, but I do have a formula to find slope. And if you don't remember that, I'm going to go ahead and put it on our board again and just remind us that it's y2 minus y1 over x2 minus x1. Remember that my subscripts are just showing me which x and y coordinates go together, because it doesn't matter which ones I use first as long as I'm consistent. Well, for the sake of reminding you how to do this from last week, I'm going to label my 2 points. So I will call this one x2, y2, and I will call the second one x1, y1. So that when I plug them into my formula, there's no way for me to make a mistake. So it's y2 minus y1. And remember, it's always subtraction. So I'm going to leave it in subtraction first, and then I will clean up my negatives. Over x2 minus x1. Well, anytime I subtract a negative, I know I am adding. So I get 9 over 2 minus 5, which is -3. Let's clean that up and simplify that, and that gives me m is -3. Great. That is step 1. I want to use my slope formula to find my m. And I just did that. Okay, now I remember slope-intercept form. I found slope, I now need to find intercept. Well, if I don't have a graph to look at, I need to use algebra. Now remember, this formula is y equals mx plus b. Well, I just found m. I need to find b. But what I don't have is x and y. But actually I do, because I have 2 points, and we know this is x comma y, or this is x comma y. So I actually have 2 points that I can use in my next step, and it does not matter which one I use. So I'm going to go ahead and let's see which one I chose to do. I'm going to use my first point, 2, 1. So let me write down where my process is going here. Y equals mx plus b. Remember, I said that's the most helpful, most useful format for a linear equation. Okay, now I already found m, so I'm going to plug that in. I'm trying to find b, so my b will remain in my equation, and that will be what I solve for at the end. Then I have an x from my coordinate, and I have a y from my coordinate. So I now have an equation. 1 equals -6 plus b. Now who knew that this equation would include both a 6 and a b? Hopefully you can still tell which one is which with my handwriting. Well, I want to get b alone because that's what I'm solving for. So I undo my addition and my subtraction next. So I'm going to add 6 to both sides. So I just found that 7 is my b, or my y-intercept. Now remember I said it doesn't matter. If I would have chosen these terms first, or as my x and my y, I still would have gotten 7 for my b. Well, now that I have my m and my b, first of all, let me write in my second step, to plug 1 point, and that's my x comma y, in, and solve for b. Now that I have that, now that I have my slope and my y-intercept, I plug those in. I write my equation. And remember, it's y equals mx plus b. My y and my x will be back into my equation, and I will fill in my m and my b. So my final answer for this example problem is y equals mx plus b. There is the equation for this line. Step 1, use the slope formula to find my slope. Then I plug in 1 point. It doesn't matter if I use this one or this one. And I solve for b. And then I write my equation. I want you to try one on your own, and it's letter A in your notes. I want you to pause this video and try that one on your own. Turn this back on when you have attempted this using these 3 steps. Okay, so I'm going to go ahead and work through this one pretty quickly here. I have my 2 points, and again, I'm going to call this one x2, y2, x1, y1. So step 1 is to use my slope formula to find m. So that is y2 minus y1, finding slope, over x2 minus x1. I know subtraction of a negative gives me addition. So my slope is 5/2. That's okay. I can have a fraction as my slope. Step 2 is I'm going to plug 1 point in and solve for b. So I go back to this mx plus b, knowing that I have 2 points here. And so what I'm going to do is I'm going to use this first one. Doesn't matter. Remember, if you use this one and you do your algebra correctly, you'll get the same answer. What is my y? It's my 2. My m is 5/2. My x is 3. And remember, my b is still in my equation because I don't know what that is yet. I need to use my algebra to solve for it. Well, my first step for order of operations is my multiplication. Then I need to subtract 15/2 from both sides to get my b. Well, I know that's going to cancel, but I now have some work to do. Just hang with me here. 2 minus 15/2. Well, for fractions, I need a common denominator. So I actually change my 2 to 4/2 so that I can subtract with my fractions. and I get negative 11 halves. Ew, but that's okay. You can see that we can still do this with fractions, but it does make it obvious that there's no way, if I would have graphed these 2 points, that I would have been able to look at my graph and said, oh, my B is negative 11 halves, which is negative 5.5. You might have been able to eyeball it or ballpark it, but you know, if you draw graphs the same way I do, it probably wasn't going to be very clear, and we want to be precise. So we need to use the algebra method. Step 3, write my equation. Y equals mx plus b. There's my equation. This is pretty tricky, and so if you haven't written down these 3 steps, pause the video and do so that you can use them for your homework problems. Okay, I'm going to go ahead and move on. The beauty of having recorded lessons is that you can rewatch this a few times if you need to when it comes to doing your homework. Let me flip my board over so that we can see number 5. Number 5 is actually where it gets kind of fun and easy to use this formula. And it's caught on my finger. Whew. Okay. So for number 5, I'm asked, what is the graph of this line? Y equals 2x minus 1. Well, when it comes to graphing, slope-intercept form is the best, because once I have y alone, I know I have y equals mx plus b as a reminder, where m is my slope and b is my y-intercept. Well, I have that here. So I know my slope is 2, and I know my y-intercept is negative 1. So to go ahead and graph that is really easy. Remember when we started this chapter, I said we need 2 points for a line, but 3 make sure that I did it right. So my first point is always my y-intercept. In this case, it's negative 1. So guess what? I know my first point is my y-intercept, where it crosses the y-axis at negative 1. Then I use my slope to find my other points. Now in this case, if my slope is 2, that's the same as 2 over 1. So that means I have my rise and my run. I'm going to go up 2 over 1. I want one more. Up 2 over 1. And so here, if I can draw, oop, that's way off. But there is my line for that graph. Not too hard. It's actually really easy in slope-intercept form. So I want you to go ahead and try letter A. Pause this video and try graphing letter A on your own. Okay, I'm going to do the same thing. Y equals mx plus b. My first point is always my y-intercept, 1, 2, 3, 4. Now remember, if I have a negative slope, I know my line is going downhill. So if my slope is negative 3, it's the same as thinking as negative 3 over 1, down 3 over 1, down 3 over 1. We have kind of, well, my graph isn't on graph paper, so there you go. Down 3 over 1, perfect, good enough. There's my downhill line using my slope and my y-intercept. Okay, letter B, I'm not going to have you pause and try on your own because I know that it's really tricky. My first thing that I need to do is to look at my equation. 4y plus 8 equals 16x. Well, right now, I know that's not ready to go. It's not in y equals mx plus b form. So I need to get it there so that it is helpful to me. So just like we did in yesterday's lesson, I need to get y alone. And before I get y alone, I have to get my y term alone. So I'm going to subtract 8 from both sides. So that leaves me with 4y equals 16x minus 8. Remember, these are not common terms. They cannot be combined. I can just write them as the subtraction problem that they are. My last step would be to divide this by 4. But if I divide this side by 4, I have to divide this and this, everything by 4. That leaves me y equals 4x minus 2. Okay, now that it's in this form, now I'm ready to go ahead and graph it quickly and easily like I did the other two. My first point is always my y-intercept. Well, my y-intercept is -2. And then I use my slope to find the other points. Remember, positive slope means an uphill line. So this slope of 4 is the same as 4 over 1, which helps me go up 4, 1, 2, 3, 4, over 1. Well, that's 2 points. I need another one. 1, 2, 3, 4, over 1. I have a very steep line here. Let's see if I can connect it. Not too shabby. There's my line. Positive slope, uphill line. Okay, for our last problem, you need to look at your handout and you see that I photocopied part of your textbook. So this problem all of these problems come straight from your textbook, but this one had a picture, so I wanted to have that in front of you. And we have a situation. We have real life problems that we can model with a function. We have actually done this many times so far this year, but this is the first time that we're going to graph them in light of slope-intercept form. So the information that I need you to see is in that first sentence before the problem, where it says that any starting value that I have is always my y-intercept. Okay, keep that in mind as we move on. Water pressure can be measured in atmospheres. That's what ATM is in this problem. It's the abbreviation for the unit of atmospheres. Use the information in the diagram to write an equation that models the pressure Y at a depth of X meters. So I wrote this in Y equals mx plus b, but I know we're going to look at our picture to find my m and to find my b. Well, my starting value is always my y-intercept. So in this case, it says at 0 meters, the pressure is 1 ATM or 1 atmosphere. Okay, well that's my starting point, because if I am diving below the surface of the water, my starting point is at 0 meters because I'm at the surface of the water. So this is my starting point. Well, what did that problem tell me? The starting value is always my y-intercept. So I'm going to go ahead and fill that in. Let me get my eraser so I can plug that in. I know that my b or my y-intercept is my starting value. Okay, great. The pressure increases by 0.1 atmosphere per meter. That's my rate of change. That's my slope. It increases, so it's going up. It's going to be a positive slope by 0.1. Well, guess what? That's my slope, my rate of change. So I'm going to go ahead and plug that in. So here's my equation. Y equals mx plus b. Well, my rate of change is 0.1, and my starting point is 1. And you can see that in the part that I showed you in your handout. Okay, now, if we were to go ahead and graph it, you would see the graph below. And it's right in front of you, right from your book. Okay, let's just talk through the got it problem there at the bottom of the page. It says a plumber charges a $65 fee for a repair plus $35 per hour. Well, we've actually been translating equations like this since our very first week of school. But remember, in light of graphing, the starting value is my y-intercept. y equals mx plus b. My starting value, my base rate. We've talked about this so many times. My base rate is $65. So that's going to be my y-intercept plus $35 per hour. Well, it tells me to write an equation, the total cost y of a repair that takes X hours. Well, if it's $35 per hour, that's my equation. Y equals 35x plus 65. We've actually written equations like this many times so far this year. But let's just go ahead and graph it. If I wanted to put this on my graph, and I'm going to draw a very basic graph here, I know my y-intercept is my starting point. So let's go by 20s. Actually, let's go by 30s for the sake of this teeny graph. So 65 would be right about here. Well, what's my slope? 35. Up 35 over 1. So if I drew that on this scale and went up 35 over 1, it would look like this. And there is my graph. Depending on what types of units you used in your graph, yours might look a little different, but that was a very basic drawing of this function represented on a graph. Okay, I know that today's lesson was a lot heavier than yesterday's. Go back and rewatch it if you need to for any of the parts, and make sure you took notes that you can reference and use as a resource. And if you wanted to watch the video through the first time and then go back in and fill the notes, that's fine too. But remember that your note packet will be collected when we return back to school. Okay, refer to your information sheet to see what practice problems you're going to do that model problems 4, 5, and 6 that we went over today, and do those in your packet. And I will see you in our next lesson.